Good evening, everybody. Welcome to O-Level Physics Revision. And these 2 weeks, we'll be going through the 2012 paper. Okay, my name is Mr. Chu. Today is 27th of September, Tuesday. Okay, so just write down the question number and your answer. And like the previous time, I'll be doing this together with you all. Okay, you all may begin. Hao-Rui, can you please on your camera? So write down 1 and your answer. Okay, I got the same answer as Yiting. Well done. How about the rest of you? You want to make it bigger? Okay, Oscar, well done. Okay, let's quickly finish the questions. Okay. Xiaoxing, well done. Bei Kuan, what's your answer? And Hao-Rui, what's your answer? Okay, well done, Hao-Rui. Okay, left with Bei Kuan. Okay, incorrect, Bei Kuan. Okay, first of all, let me just begin by sharing you how to do this question. Okay, so you look at this. Okay, so this is a micrometer screw gauge. Okay, so this will be 1 cm. So for here will be 0. Then this one will be 0.5 cm. And then this one will be 1.5 cm. Okay, all clear about this so far. Okay, and then it's pointing to this point, which is 34. Okay, which is 34. Okay, so this whole thing will be 1.5 plus 34. Okay, so 1.5 cm plus 0.34, you'll get 1.84 cm. So to read this thing, okay, 1 cm, then half a cm. At this point is 34, so it's 1.50 plus 34, you'll get 1.84 cm. Bei Kuan, are you able to read this? Okay, it's not 1, 2, 3. It is one big interval is 1 cm. Okay, are you clear, Bei Kuan? Okay, so now you know that this reading is 1.84. But when you close it, it has a positive, okay, it has a positive 0.03 cm value. Meaning that when there's nothing there, you got extra 3. So for your final reading, do you take away the 3 or do you add the 3 there? So when there's nothing, they tell you that you are actually 0.03 cm tall. Then we measure something. This is the extra. Is that clear? Okay, so the zero error is plus 0.03. So to find this value of this metal sheet will be 1.84 minus of this 0.03. Then we get this one. Clear? Can okay, so should it be mm or cm? I also confused now. Okay, so are you clear about this? Okay, let's move on. Okay, you all understand why is it 1 and not 3? And you understand this is the positive. Okay, let's continue. Next question. Pei Kuan, are you clear about this? Okay, do question 2, everybody, quickly. Okay, Yi-Ting has got the answer. I haven't got the answer yet. Okay, I got the same answer as Yi-Ting. Well done. Oscar, well done. Okay, the first one, the answer will be this. Hao Rui, well done. Qiao Xing, incorrect. Pei Kuan, incorrect. Qiao Xing got it correct now. Well done. Pei Kuan still incorrect. Okay, so the aircraft is moving in the northeast direction. Northeast. Okay, so this is the aircraft is moving in the northeast. So all these are correct. Very good. Because this is northeast, correct? Then the wind is blowing to the northwest. So this is northwest. So this one is wrong. Okay, this one is correct. This is wrong, and this is correct. Okay, so B and D are both wrong. So which one is the correct answer? So the two vectors by the aircraft and the wind are correctly represented by A and C. So which one will show you the resultant force? Is it the A or the C? Okay, Pei Kuan, well done. Okay, who's the last student that did not give me the answer? Oh, Ryan. Okay, he haven't come in yet. Okay, so for this, the answer will be A. Is that clear? Pei Kuan, Qiao Xing, you understand now? You understand? Give me a yes reaction, please. Thank you, Pei Kuan. Qiao Xing, are you okay? All right, question number 3. You all may begin. Write down the question number and then you answer. Ryan, well, you're very fast. Well done. Yi-Ting, well done. Oscar, well done. Qiao Xing, well done. Okay, last two students. Hao Rui and Pei Kuan. Okay, all of you got it correct. Okay, so average speed. The formula for average speed is total distance over total time. So you got the time here. Area under graph is your distance. Okay, so to find the average speed, you need the total distance, which is area under the graph, You need a total time, so the total time taken is written here. So the answer here is A. Well, like everybody all A today. Okay, well done, everybody. Let's continue. Okay, question number 4. You all may begin. Okay, I got the answer already. Yeah, I got the answer already. Write down your question number, then your answer. Bei Kuan, well done. Yu Ting, well done. Ryan, well done. Qiao Xing, well done. Hao Rui, well done. 1, 2, 3, 4, 5. Who's the last student? Oscar. Well done. So everybody understand this question? I will not talk about this. Acceleration is a constant and there's an increasing velocity. Okay, let's do question number 5. You all may begin. Okay, I got the answer already. Ryan, well done. Hao Rui, well done. Yu Ting, well done. Qiao Xing, well done. Oscar, very good. Bei Kuan, very good. Okay, all of you understand this question? The answer is C. Very, very good. Let's continue. Okay, do question number 6. You all may begin. Okay, I got the answer for this. Hold on. Bei Kuan, is that your previous answer? Okay, Bei Kuan, well done. Wait, you changed your answer. Okay, sorry. Oscar, well done. Bei Kuan, try again. Yu Ting, well done. Ryan, well done. Bei Kuan still incorrect. Bei Kuan, you're just guessing. Oscar, can you show your working onto the screen? The rest of you, can you all please give me the answer? Qiao Xing, what's your answer? Hao Rui, well done. Hey Ryan, why you give me question 7? Later lah. We finish 6 first. Oscar, can you give your working on the screen? Okay, Qiao Xing, well done. Okay, Oscar, you give your question right now. You show your working on the screen and teach Bei Kuan. The rest of you can do question 7. Okay, Yu Ting, 7 correct. Qiao Xing, 7 correct. Ryan, your 7 is correct. Well done. Oscar, are you doing? Question 6. Okay, question 6, the answer is this. Okay, how to do this question? Okay, to find the initial acceleration, you must know that the A is equal to F over M. Is that clear? And then what is your net force? Okay, so the rocket is like this. This is your thrust and this is your weight. So your net force is equal to thrust minus weight. Is that clear? Okay, so it's thrust minus weight divided by M. Then What is the weight? Weight is equal to mg. Clear? Okay, so now with this, can all of you just sub in everything? Okay, sub in everything. Okay, you will get the answer 0.625 meter per second square. And because in your question, they are all given 2SF and 2SF, your final answer shouldn't be more precise than the thing given in the question. So therefore, your answer will be like this. Okay, also Oscar showed the answer. Is that clear? Pei Kwan. Okay, so for question 7, can you quickly show your working? Okay, Oscar's working, not so good. Let me explain to you why. These two things are not equal. Okay, if you want to write down, you must write like this. Weight is equal to mg. Then you write down 3.2 times 10 to the power of 6 times 10. Then you get the answer. Because the mass is not equal to the weight. Oscar, you clear? Okay, Oscar, your 7 is correct. Very good. Okay, the resultant force, okay, is this. Well done. So you put F equal MA, you should get the answer. Okay, very good. Okay, so this is the working by Oscar. Okay, so Oscar, you understand the first sentence why I say that it's not correct? The first statement. Okay, so for question 7, how's the answer for the rest of you? I'm left with Pei Kwan, the last student. Question 7, where should you put the one weight so that the whole thing will balance? Okay, very good. For question number 7, the answer is B. If you put one weight here, this moment will be one weight plus one distance. Okay, for this moment, it will be a 2 weight multiplied by 4 distance. Is that correct? Then for this, the moment will be 3 weight multiplied by 3 distance. So in this case, the moment here is 9 WD. Here you add together, you also get 9 WD, and therefore you must put at B. Is that clear? Okay, all good. Let's continue. Okay, do question number 8. Yeah, I got the answer already. First to give me the answer is Xiaoxing. Well done. Correct. Yiting, very good. Pei Kwan, excellent. How are we? Well done. Ryan, well done. Okay, all of you got the correct answer. So let me just briefly tell you first, this is your weight. Okay, so your weight is 2.0 Newton. So how do you find the perpendicular distance? You extend the line of force, and this is your perpendicular distance, which is equal to QC. Okay, so moment will be equal to the force. This is your force multiplied by the perpendicular distance. You'll get the answer 0.6, and you'll turn clockwise. Is that clear? Okay, next one. Let's do question number 9. Okay, quickly do, everyone. Question number 9. Okay, I got the answer already. Who give the first answer? Ryan, well done. Hao Rui, well done. Oscar, well done. Yu Ting, well done. Wei Kwan, well done. Who's the last student? Last student is Qiao Xing. Incorrect. Qiao Xing, incorrect. When you heat up something, it will expand. When it expands, surface area go up. Your volume also will go up. Okay, then density is the mass over volume. So when your volume go up, your density will go down. Is that clear? Because as your volume go up, your density go down. Chelsea, you're still not correct. The density will not become constant because your volume go up, density not go down. So what's the answer for question number 9? Chelsea, what's your answer for question number 9? Okay, so only the mass remain constant because mass means amount of substance in the body. So when you heat things up, the number of molecules will still remain the same. Is that clear? Okay, so only the mass remain constant. Okay, very good. Let's do question number 10. 10, 10. Wow, you all give me the answer already. I haven't have the answer yet. Let me go and count with my calculator. Okay, I got the answer already. The first to give me is Chelsea, well done. Ryan, correct. Hao Rui, very good. Yu Ting, excellent. Oscar, perfect. Who is the last student? Last student, Mei Kwan, where are you? Hey, Kwan, are you there? You got any help? Do you need any help? Hey, Kwan, are you there? Okay, Pei Kwan incorrect. Okay, first of all, can you find the volume? Okay, the volume. Area multiplied by the length. Area is this. The area is 5 times 4 minus 3 times 2. Correct? The length will be 10. This is the length. So this is your volume. You will get how much? Okay, you will get 140 cm cube. Okay, then you know density is 10. So density is equal to mass over volume. I make mass the subject will be density times volume. So density is 10 gram every 1 cm cube. And this whole thing take up a space of 140 cm cube. So what would the mass of this thing be? Okay, it will be 140 times 10. You get 1,400. Okay, Pei Kwan, you understand how to do this now? Yes or no? Or still confused? Can let's continue. Okay, question number 11. You all may begin. Okay, I got my answer already. Okay, Ryan, well done. How are you? Very good. Oscar, excellent. Yu Ting incorrect. Pei Kwan, well done. Okay, I think the tricky thing would be, it says, what's the pressure exerted on the block by the table? Okay, I think some of you get confused by this. Yu Ting, well done, correct. Okay, so Yu Ting at first chose this one, R, the weight of the R. The weight of the table is acting downwards, not upwards. Okay, so whatever that is acting downwards on the table, they'll get equal opposite force acting upwards by the table. Okay, so your pressure is force over area. So this force is your weight of the block Q. Area will be the area of the block X. So therefore the answer is A. Can? All good? Very good. Do question number 12. You all may begin. Oh, your answer so fast. I haven't counted yet. Okay, I got my answer. Ryan, first to get it correct. Very good. Howry, well done. Eating, excellent. Oscar, very good. Bei Guan incorrect. Xiao Xing, well done. Okay, so for this, you have the C. On top, there is an atmospheric pressure acting on it. So this is the 1.0 times 10 to the power of 5. Then you got the fish, which is also have another amount of pressure acting on the fish. This one, the height is 8 meters. So the pressure due to the water, the pressure here due to the water on top of it is equal to H rho G. Your H is 8, your rho is 1000, and your G is 10. Then once you find how much pressure on top of the fish, the 8 meters of water on top of the fish is acting on the fish, is that the final answer? This will be 8 times 10 to the power of 4 Pascal. Okay, you don't stop there. There's another 10 times 1 times 10 to the power of 5 Pascal of pressure pushing downwards. So you need to add the atmospheric pressure plus the pressure due to the 8 meters of water. Add them together and you get the answer. Okay, Bei Guan, what's your answer now? Okay, very good. So the answer will be D. Okay, I'll do question 13 now. 1, 3. Begin. Okay, I got my answer. Question 13. Ryan, well done. Bei Guan, try again. Hooray, eating, very good. Okay, so when there is no friction air resistance, it means that no energy is lost. So the energy here is equal to the energy here. is equal. Okay. So Pei Kwan, try again. Oscar, well done. Pei Kwan, try again, try again. Pei Kwan, you need any help? Okay, very good. Okay, so on the top here, you have two energy. You have the gravitational potential energy and you have the kinetic energy. So you have the total energy and this energy will be the KE here. They are the same. Is that clear? So the answer will be 9.8 joule. Clear so far? So you know the, okay, let me just for the sake of this video, the GPE formula is mgh. The KE formula is half mv squared. Clear? Okay. Let's do question 14. We are slightly behind time. No, we are quite behind time. Should be at almost 20 now. Well, answer coming already. I haven't do yet. Let me see. Okay, I got my answer. Ryan, correct. Yiting, you try again. How well done. Yiting, very good. You got it correct now. Oscar, very good. Pei Kwan, well done. Okay, so power is equal to energy over time. Correct? Okay. So energy over time. So energy is equal to, in this case, we are climbing up the stairs. So can you say that it's the same as mgh over time? So height is constant. Mg is the weight. So if my W over T is the highest, you'll give me a greatest power. So I just do the first two lah. So I use W over T, I will get 30 here. Second one, W over T, if I use my calculator, I'll get about 33. So you go and find all these 4 W over T. Okay, you'll realize that B has the biggest value. Is that clear? Okay, but what I'm trying to teach you is this. Force over time is not power. But why do we use force over time to determine which one has the greatest power? Because power is energy over time. Energy over time is the same as if you use gravitational potential energy, and that will be mgh. And then when we talk about when all of them run up the stairs, their height will be constant. So you can just consider the weight of every individual. So the greater the weight in a shorter amount of time to do this, definitely has the most power. Can? Okay, let's continue. Question 15, you want me to begin? Okay, question number 15. Ryan, first to get it correct. Eating well done. Oscar, excellent. Hooray, very good. Chelsea, incorrect. Okay, what's your answer? Okay, well done. Okay, Chelsea, you know what's your answer? Okay, so when you pull it out, the volume increases. So the molecules has more space to bounce around. Okay, so they actually you have less likelihood to hit each other. So the pressure will actually decreases. Okay, and there's no other external. Okay, then when it says that when internal energy actually can represent, it actually tell you more about your temperature. So when internal energy is unchanged, your temperature will be unchanged. Okay, so therefore the answer is B. Okay, Chelsea, understand now? Ken? Hello? Ryan, where's your camera? Are you eating now or in toilet? Okay, question number 16. You all may begin. Okay, I got my answer already. Eating, well done. Ryan, well done. Chelsea, well done. Alright, well done. Oscar, well done. Okay, very good. The thing that actually is bouncing around is actually air particles hitting the smoke particles. Okay, it's not a small particle dancing. Why is it hit moving around? Because as it moves, it hit other air particle which is invisible, and therefore what you are seeing is the random movement of the smoke particle. Okay, clear? Let's continue. Okay, do question 17. You all may begin. Okay, I got my answer. Bei Kwan incorrect. Ryan, well done. Hao Rui, well done. Chelsea, excellent. Yu Ting, incorrect. Bei Kwan, you're confused. Incorrect. Oscar, incorrect. Okay, definitely A and B are wrong. Okay, so what would be the correct answer? Okay, this part here is correct. This part here is correct. So it should go down all the way to 20 or not to go to 20. How do you tell? The clue here is after some time, the wax starts to melt. If it did not melt, see, okay lah. But if it start to melt, it means that the temperature is higher than room temperature. Is that clear? Okay, so therefore, the correct answer for this is D. Are you clear? Are you clear? I say Oscar wrong, man. Let me see. Did I say you're wrong, Oscar? I'm sorry. Okay, are you clear about this, everyone? Sorry, Oscar. Okay, question 18. You all may begin. This one we talked about it last week, right? The thermocouple thermometer. Okay, I got my answer. 18, Ryan, Yu Ting, Hao Rui, Chelsea, correct. Oscar, correct. Bei Kwan, incorrect. Okay, for this to work, okay, the temperature has to be different. Okay, it has to be different. It cannot be the same. Okay, so this will be correct. These two will be wrong. Then for this to work, is everything is the same wire, there'll be no difference in potential difference. So the material of X must be different from copper. So you see copper, you'll be wrong. Okay, so for Bei Guan, what's your answer? Bei Guan, what's your answer? Hello, Bei Guan. Okay, clear? So the answer will be B. Is that clear about this? Let's move to the next question. Okay, now we need to accelerate the time. Do question number 19 very quickly. Quickly do. Okay, I got my answer. Ryan, well done. Oscar, well done. Peter, well done. Hao Ray, well done. Bei Guan, are you confused? I'll give you a clue. The formula will be this. This is the formula that you need to memorize. If you cannot remember, you look at the unit to give you clue. So specific heat capacity is C. Okay, so this is C. C is energy divided by mass and temperature. So if you cannot remember this, you can use the unit to give you a clue to derive the formula. Can? Still incorrect, Bei Guan. Do any of you want me to explain how to use the unit to derive the formula? If anybody want, give me a yes reaction. If don't need, then no reaction. Hello? I never say no. I mean, give me the cross reaction, not don't give me no reaction. But anybody need me to explain how I use the unit to derive the formula? Don't need, okay, so the rest don't care. Dreaming. Okay, so Bei Guan, what is your answer? Okay, so you want to do this question, your temperature is equal to Q over MC. Okay, Bei Guan, what's your answer now? Bei Guan, Q is energy. This is Q. This is M. This is C. Hello, Bei Guan. Okay, Chelsea, well done. Okay, so which of these answer is this? Which of these answer is this? Okay, well done. So for this question, the answer is C. Clear? Okay, all of you now do question number 20. You may begin. Wow, so fast, some of you. Okay, correct. Chelsea correct. Ryan correct. Yuting correct. This one is either you know or you don't know. Hao Rui, Bei Guan, why your answer is Q? You got Q, man? Bei Guan incorrect. Why? Because this axis is time. Hao Rui, well done. If this is distance, you can say it's wavelength, but this is time. Oscar, correct. Bei Guan, correct. Okay, understand? Okay, so if it's time, one wave is the period. If it's distance, then one wave is the wavelength. Clear so far? Okay, so for this question, the answer is A. Okay, why is it not half? Can you see? She can move from here to here. So why is P not half? Because amplitude means the maximum displacement. Okay, what does displacement mean? If all this started off as a particle, the maximum you move away from the original position. The maximum distance you move away. This is the maximum displacement. We call it amplitude. So P is the maximum displacement from the original position. Okay, are you clear about this? Good. Let's continue. Question 21 quickly. Okay, I got my answer. You got your answer faster than me. Okay. Ryan, well done. Chelsea, excellent. Ray, very good. Eating, perfect. Wei Guan, well done. So basically for this question, the key formula is this. This is fixed, okay? So you know that V over lambda. So basically V1 over lambda 1 is the same as V2 over lambda 2. Okay, you just sub in this, you should get the answer. Okay, well done, everybody. All got correct. So the answer will be A. Is that clear? Well done. Okay, question 22, quickly do. Okay, for this question, most of it got it correct. Well done. Chelsea, well done. Ray, well done. Oscar, well done. Bei Guan, incorrect. Chelsea, well done. Wait, Chelsea, sorry. You're giving me 23 already. Wait lah, not so fast. Eating, well done. Okay, let me share with you how to do this question. First of all, you need to extend the mirror. Can? And you also, all of you also know that the distance of the object to the mirror is equal to here. Understand so far? So your image is here. The image due to the pink color line is here. Clear? Then same thing. This is your mirror. So this I is your new object. Here is your new object. Clear? And then this new object is now reflected onto the green line. So let's see how long is this new object. I use the orange color. Okay? If it's the orange distance in front of the mirror, your image will be the same distance behind the mirror. Okay, so therefore the answer is D. Are you all clear about this? You understand why is it D and not the rest? Pei Kwan, you clear about the explanation? Ryan, are you okay? Oh, okay. Okay, let's do 23. 23. Okay, let me look at the answer that y'all give me. 23. Howry, well done. Yuting, well done. Ryan, well done. Oscar, well done. How about the rest of you? Okay, Pei Kwan incorrect. Okay, so the angle of incidence is less than the critical angle. So no total internal reflection will take place. Okay, so C is wrong. Okay, because this angle of incidence is less than the critical angle. So C will be totally wrong. Yeah, but because this value is very near the 43, okay, by right, it should be refracted into the air. But it's so close, because there's a surface down there, some of the light will still be refracted back. Okay, but majority will be refracted into the air. Okay, so the answer for this is B. B, is that clear? Mr. Pei Kwan, you understand? Okay, next one. 24. You may begin. Okay, for question number 24. Yu Ting, well done. Hao Rui, well done. Qiao Xing, incorrect. Ryan, incorrect. Ma Qiao Xing, second answer is correct. Well done. Oscar, well done. Pei Kwan, well done. Okay. Since O is the center and this is like a circle, right? Can you see this? Something like a circle. Okay. And these are all like radius. So when O hits the curved surface, it should go straight. Okay, it will not bend. So these two are correct. Okay, it will not bend at all. Understand? Are you clear about this part? Then the question says that it's diverging, means it will bend away. Okay, so if I were to continue drawing the line, okay, I continue drawing a line. And for this, I'll continue drawing the line. But because this O and the center is like cutting through half the thing, is bending to down and bending up, is bending away? No. Okay, whereas for the first line, this is bending away. Okay, but because this line here is right in the middle, or we call it the axis. Okay, the light will continue to go straight. Is that clear? Just like when we have a converging lens. You have a light in the middle, you'll continue to go straight. Even though the light at the top will bend down, the light at the bottom will bend up. Okay, but the light in the middle will always go straight. So same thing, the light in the middle should go straight, and therefore B is wrong. Okay, are you clear about this question? If you understand, give me a yes reaction. Okay, you understand this question? Give me a yes reaction. Hurry, hurry. Very good. Xiaoxing, okay? Xiaoxing, understand? Good. Let's do the next question, 25. You want me to begin? Okay, 25, Yu Ting correct, Oscar correct, Hao Rui correct, Xiaoxing correct. Two more students. Bei Kwan, well done. Ryan, very good. Okay, for this is a factual question. The answer is B. Clear? Anything down here you want me to clarify? Okay, well done. Let's continue. Okay, do question 26. Okay, question number 26. Yuting, well done. Ryan, well done. Xiaoxing, well done. Bei Kwan, well done. Oscar, well done. Hao Rui, well done. And all got correct. Okay, the answer here will be C. Okay, this is the middle. This is the middle. So from middle to middle will be the one wavelength. But there's no middle to middle, right? So you look at the one beside that. So the answer C will be correct. Okay, very good. Question number 27. You all may begin. Twenty-seven. Yuting correct. Ryan correct. Hao Rui correct. Xiaoxing correct. Oscar correct. Very good. Where is Bei Kwan's answer? Bei Kwan. Well done. Okay, so when the lines are nearer, it is stronger. So M are very near, so it's stronger compared to K, which is very far. So in this case, the answer is B. Okay, now let's do question number 28. Okay, 28, you may begin. Hao Rui, well done. Bei Kwan, well done. Yuting, well done. Ryan, incorrect. Oscar, well done. Okay, the keyword here is near. So they don't touch. Okay, they don't touch. Okay, Ryan, correct. Xiaoxing, correct. So when they don't touch, here will be a bit negative. Here will be a bit positive. Then when you move aside, if this is negative, okay, this will become positive. Is that clear? And the charge will be the same. Understand? So the answer here will be D. Continue. Question 29. You all may begin. Okay, I got my answer. How about you? Bei Kuan incorrect. Ryan well done. Yu Ting well done. Hao Rui well done. Oscar well done. Bei Kuan correct now. Because you are trying to find out the current of the diode versus the potential difference of the diode. Understand? So why do you want to put the potential difference over the battery? Okay, so answer for this is D. Okay, this one is obviously wrong. You don't put your ammeter in parallel. Okay, and then you also don't put your voltmeter in series. Okay, so these two are obviously wrong. Okay, so you are trying to find out when you vary these rheostats, this V will change. Is that clear? So when your resistance change, this V will change, and then you can see what is the current flowing through it. Clear, everyone? Okay. Next, question 30. Ryan, well done. Yu Ting, well done. Well done, well done. Bei Kuan, well done. Oscar, well done. Hao Rui, well done. And the last student is Xiao Xing. What's your answer for 30? Okay, very good. So basically a rectifier is using 4 diode to actually convert AC to DC. Okay, now I'll do question 31. You all may begin. Yu Ting, well done for 31. Oscar, well done. Hao Rui, well done. Ryan, well done. Pei Kwan, well done. Who's the last student? Chelsea, what's your answer for this? Chelsea, are you there? Chelsea, what's your answer? C or A? Correct. Okay, so those who are confused, basically you just need to like do like this. They are all in parallel. So I1 is the same as I2 is the same as I3. And since I is equal to 1.5 ampere, I1, I2, I3 will be the same value. So which of these A, B, C, D will show 1.0? The answer will be A. Okay, are you able to see it now? Is it clearer? So you see too many ammeter, right? I'll take out. It only distract you. You draw like this, will be much clearer. They are all identical lamps, and they are all parallel, so their V are all the same. And since their resistance are all the same, the current going through them should be the same. Okay, so that's how you do this question. Let's continue to the next question. Do question 32, you may begin. Okay, question 32. Ryan, well done. Hao Ray, well done. Yuting, 32, correct. Bei Kwan, incorrect. Incorrect. Oscar, well done. Chelsea, well done. Okay, Bei Kwan. So how do you find the total resistance? When they are parallel, 1 over RT is equal to 1 over R1 plus 1 over R2. Okay, so you let R1 be 2. You let R2 be 2000. Can you find the total resistance? You make RT the subject. What will be their answer be? Okay, you will get about 1.998 ohm. So at first is 2 ohm. Now the resistance becomes slightly lesser. So your current will be slightly more or slightly less. Okay, very good. So when your resistance is slightly lesser, your current will be slightly more, and therefore your answer is D. Clear? Okay, next question. We are ending. We do question 33 now. Okay, oh, okay. I also blur. Yiting, well done. Ryan, well done. Hao Rui, well done. Chelsea, incorrect. Bei Kwan, well done. Oscar, well done. Okay, Chelsea, you need me to help? So this point here is the same as this. So it's 6 volt. Okay, because this is 10 ohm and 10 ohm, right in the middle here would be 3 volt. So Y will always be 3 volt. So as X move from P, at point P will be 6 volt, at point Q will be 3 volt. So at first, the difference is 3 volt. Subsequently, the difference will be 0 volt. So it will decrease from 3 volt to 0 volt, and your answer is B. Chelsea, you understand how to do this question now? We just did this recently. Can? Let's continue. Okay, question number 34. You may begin. Okay, for question 34, as the resistance of the thermometer will go down when the temperature increase. Okay, and the power supply or the V is constant. So V is equal to Ri. As the resistance goes down, this is a constant, your current will go up. So C and D are wrong. So the question now is the answer A or B? Okay, so Ryan, you know why C is wrong, huh? As the resistance will decrease, right? So your current should go up. Okay, so let me look at the answer by your Hao Rui, well done. Yu Ting, well done. Ryan, try again. Qiao Xing, incorrect. Oscar, well done. Where's the last student? Bei Kuan, what is your answer? Okay. So, Bei Kuan incorrect. Okay, it says that the current will go up. But look at B, it becomes constant. Okay, so this part here, when it becomes constant, is wrong. Okay, so therefore the answer will be A. Are you all clear about this? Can? Okay, so we will just end here today because the rest of the question we have done very recently. Okay, so we will just go back to your video if you want to try this out. So we'll end here. How many of you want to continue? Want to continue one? Give a yes reaction. Do want to end here one? Give a no reaction. Come, give me some feedback. Ryan asked, would there be a limit to the resistance? So you when it becomes like this, it means that the resistor become lesser and lesser and lesser to a point that you'll just stop there. Okay, you will tell me whether is there a limit to resistance, it should be something like maybe like this, D. Okay, so this is still not, it did not go up all the way to the end. Okay, so the answer will be A because the question says when the temperature increase, resistance decreases. But at this part here is a constant. So it doesn't apply to this question. Is that clear? Why Beikon disappear already? Okay, so you'll give me a reaction. Continue, yes reaction. Stop, no reaction. Majority win. We'll do question by question. No reaction, I'll continue to the end. Hello, give some feedback. Hello, continue or no continue? Okay lah, no reaction, we continue. Next question. Okay, do question number, no, this one. This one, you all may begin. Question number 35. What is the total current? Okay, I got my answer already. What is your answer for question number 35? Yu Ting, well done. Xiao Xing, well done. Hao Rui, well done. Ryan, well done. Oscar, well done. Bei Kuan, well done. So all correct. Okay, very good. This question you use power equal to IV. You find the I of each current, you add them together, you should get 0.75A. Okay, give in 10 seconds. Yes to continue, no to stop, nothing to continue. Come. Nothing, so we will continue. I only got one vote. So 5 no vote, we continue. Next question, question 36. You all may begin. Okay, I got my answer for this already. Okay, 36. 36. Wei Kuan incorrect. Yi Ting incorrect. Ryan, well done. Xiao Xing incorrect. Howry, well done. Xiao Xing incorrect. Oscar, well done. If I change the resistor to a light bulb, which one will give you the brightest light? The brightest light means you use up the energy the most, correct? So can you all try again? Xiao Xing, well done. So if I change it to a resistor, which one will give the brightest light? The three bulb will be the brightest. We ignore these two, I should confirm not correct. So which one will give you the brightest light? B or D? Okay, Xiao Xing, well done. Yu Ting, well done. So if I use a light bulb example, you remember I told you all in parallel, the current will be the same, whereas if you are in series, the current will be lesser because the resistance is higher. So this three bulb will be dimmer compared to this three bulb. So this three bulb actually is brighter, you use up more energy. Okay, 10 seconds, give me your vote. Yes to continue, no to stop, no feedback, also continue. Okay, 5:1, let's continue. Because the rest don't bother. Come, 37. Which one is the correct magnetic field pattern? Thirty-seven, Yu Ting correct, Ryan correct, Howry correct, Oscar correct, Xiao Xing correct. Who's the last student? Wei Guan, what's your answer? Incorrect. Okay, so when you have a current going in using your right hand grip rule, your thumb go into the picture. Wei Guan still wrong. Okay, the magnetic field will be clockwise. Okay, so this one is wrong. This one is wrong. So this two is correct. This two is wrong. Okay, so therefore, what's the answer? Okay, well done. The answer is B. Are you clear about this? Okay, yes to continue, no to stop, and nothing to continue. Okay, no reaction. Let's continue. 38. What's your answer? Okay, 38. Yu Ting, well done. Xiao Xing, well done. Howry, well done. Oscar, well done. Well done. And Ryan incorrect. So at first it comes down. On top, you'll be acting like a north because you have the resist coming down. Then as it goes away, away. You want to attract it. So now the bottom will become north instead of the top. So the direction of the emitter should be the opposite. At first it's right. So when it comes down, you try to oppose, you become north. Then when it goes down, okay, don't goes down is like trying to repel, right? So here I want to attract. So second time around when it's leaving, you want to be like north. So it become north and south. Okay, so the answer will be C. Is that clear? Yeah, since we are here, we just finish the last two questions. Oh, okay. Last two questions. You all may begin. What is this thing? All right. Yiting, perfect. Ryan, very good. Oscar, well done. Hao Rui, well done. Bei Kuan, well done. Okay, well done. Answer is slip ring. Let's continue to the last question of today. Last question. You all may begin. Okay, I got the answer for 40. Took me a while to calculate. Hao Rui, well done. Yiting, well done. Oscar, well done. Ryan, try again. Okay, our Ryan, well done. Xiao Xing, well done. Bei Kuan, well done. Thank you very much. See you all next week. Good night and goodbye. Bye-bye.